So let's understand what the question is saying. That very first, if you see, we have given this grid. This grid is n cross n binary grid, right? As you can see, this is n cross n binary grid, means this will be either 0 or 1. That is called a binary grid, right? Binary grid. We can only swap adjacent rows. Like if this is the row, multiple rows are there, let's suppose, right? We can only swap the two values, right? Adjacent rows, this row and this row, right? This is the row I, this is the I plus 1 row, right? See, if there is two elements are there, we can swap like this only. Okay, so our goal is to rearrange the row so that for every row I, because it's I, right? So it will keep moving ahead. So for every row I, all elements above the main diagonal. So this is the main diagonal, guys. Okay, if you see, this is called the diagonal, this is another diagonal, right? Like this. So it is saying above the main diagonal is uh above the main diagonals are zeros, right? As you can see. So let's try to understand here is, if we want to say that about the row, okay, let me tell you. Yeah, it's very important to understand. Okay, so I am saying what is our goal, right? First understand our goal. It is very important to understand our goal. For every I, means every row, this is called row, right? So for every row, we can say all the elements above the main diagonal must be 0. Okay, for every row. What does that means? It means, we can say, it means if we have row 0, means we need, yeah, it needs at least n minus 1 trailing zeros. Okay, if we have row 1, it means we need at least n minus 2 trailing 0, right? If we have row 2, so on, we can say n minus 3 trailing 0, and we have to keep going like that, and we'll say row n minus 1, if it needs n minus 1, so we can say that is 0, right? 0 trailing zeros. Okay, if impossible, it means we have to return -1. I hope you are understanding what it is. I say that for give me a second, for every row, right? For every row, all the elements above the main diagonal must be 0. For row 0, what does it mean is that for row 0 needs at least n minus 1 trailing zeros. For row 1, n minus 1. For row 2, n minus 3. For row n minus 1, we need 0 trailing. So it is if it is impossible, these things, right? If all the elements, like if it is not possible to generate this, right, then it is impossible, so return -1. This is our goal, guys. This is our goal. Our goal is to, for every row, all elements above the main diagonal must be 0. It means Row 0 is n row 0 needs at least n minus 1 trailing 0. Row 1 needs at least n minus 2 trailing 0. Row 3 n minus 3, so on. We can say we need, in the last row we need 0 trailing here, and it is impossible, then return -1. Okay, I hope you are understanding. Now think that, okay, what is important? Let's think. The very first, we have to understand important thing, very important thing. What is very important? Very important that we do not care about full row, full row content. Okay, guys, means we do not care about the full row content. Means we only care about how many trailing zeros each row has. Understand? Why? Why? Because we can say, because trailing 0 determines because trailing 0 determines if the row can satisfy, right, diagonal condition. Okay, if this is happening, because the trailing 0 determines if the row can satisfy diagonal conditions, means, right, we do not care about the full content, we only care about the how many trailing zeros each row has, because trailing 0 determines if the row can satisfy diagonal condition. Easy. Let's understand by the example. Let's suppose that we have a grid, right, and this grid contains, let's suppose, 0 0 1 1 0, not 0, let's take here 1 1 0, this one. Then take 1 0 0 like this. If we have a grid and we have the elements like this, okay, if we have the elements like this, okay, guys. So very first, in the steps, what we should understand, let's try to understand. We were talking about that in step 1, let's say, count the trailing 0. Okay, okay, so we'll talk about row 0. So row 0 have one trailing 0, right, one trailing 0. Let's talk about row 1. Row 1 have one trailing 0. Then let's talk about row 3, not 3, 2, 0 1 2. This is row 0, this is row 1, this is row 2. I know you know that, right? So here we have two trailing zeros. Okay, so we convert this grid in trailing array. Are you understanding what I'm trying to say? It means, so we need to convert the grid into No, what we are going to convert? We are going to convert into an array. What will be the array? Let's say if I create like this, okay. So for 3 row, I'll say 1, 1. So this will become our array, and the array we have we have 3 rows, so we'll convert into this one. Okay. It means we required the condition per row. What is the required condition? It's very important to understand the required condition per row. Let's think carefully. Okay. Let's suppose we have for n equal to 3. Okay. If I'll say we have a row index that start from 0, 1, 2. What is the needs trailing 0? Trailing 0 should be greater than equal to what? If row 0 is there, trailing 0 needs trailing 0 is 2. If 1, we need 1. If need 2, we need 0. Like this we should have, that we know, we have seen, right? Okay guys, I hope you understanding. Okay, so this is the required condition per row we have. So let's try to understand here. If we will say that, okay, let's do the stepwise row placement. How we are going to do is the how we'll use the pointer in this concept. Okay, so we know that we have given the array like 1, 1, 2. This was the thing, right? 1, 1, 2. Yes, 1, 1, 2. So these are called array of zeros, right? What is the index is there? So index is 0, 1, 2. Correct. Now point 1, the position we are talking about is 0, which needs how many zeros? Greater than equal to zeros, that we have seen, right? 0 needs 2 trailing zeros. So we can scan a downward. Correct. How? Let's think. If we will check the index 0, it is 1, means it is not correct. Then we'll check index 1, it has 1, that is not correct, because if you see 0 needs 2, 1 needs 1, right? Like that. So we have to check which index we have. Let's check index 2 having 2. This is correct, right? Means we found at index 2. Understand? We found at index 2. So now bubble it upward. Okay, now bubble it upward. It means what is the meaning of this? It means we have to do adjacent swaps. Remember the question was saying that part we have to do now. It means, let's suppose we have the array 1, 1 and 2. So if we want to do swap with the index, right, means let's swap with index which is 1. It means it become array become what? 1, 2, 1, like this. Now if you want to swap with index 0, it means it become like what? 2, 1, 1, and the total swaps required is 2 to satisfy the condition, right? So it means what? The thing we are talking about is we need step-wise row placement, where we saw that position 0 needs greater than equal to 2 zeros. It is correct, we can do, it is possible. It is possible by how? It is possible only if we'll swap 2 times upward, right? And that is why we got that. Now same thing we have to do for the position at 2. Let's suppose, let's position at 1, 2 we have already seen. Position at 1 we needs is greater than equal to 1 0, correct? If you remember, let's go back to the index. I'll show you here. So position 1 needs how many? 1 0, right? So let's do the same thing for him. Now think that now we have the array like 2 1 1. Let's check at index 1. Check index 1. It is already having 1 0, means no swap needed. You have to think like that, okay? Then we have for the position, means the index is 2. We have checked, right? So 2 needs what? Greater than equal to 0, that we have seen, right? Let me check again. Yeah, 0 1 and 2. So this row needs here is 0, right guys? So let's do for this. So here there we have is its needs greater than equal to 0. It's already satisfied because there is only one row is there, right? One is there, so it's also satisfied, means always satisfy here, okay? So that the final answer is how many step required? It required 2, that we have seen. This is the answer we have, guys, okay? So we should think about how we are thinking. If it is, we have seen that position 0 needs greater than equal to 2 zeros. So we have scanned downwards and we have seen that we have checked the index each time, right? So we found that at index 2 we have 2. So we have bubbled it upward, or we have done the adjacent swap, right? It means after the swapping, this array becomes like this, and again we will do the swapping, it becomes like this. So very first index 0 got the 2 swap and it found 2 zeros, and for this 1 1 we need, for position 1 we needs greater than equal to 1 0, so that is fine. For position 2 also we got only 1 there, that is also satisfied. That is why the answer is 2. It means the intuition behind this approach is basically greedy row placement we are doing with the what do you call, the bubble, right? Bubble up swaps. Why this greedy works? Because the top row needs the most zeros. If you delay the placing a valid row, you may lose the opportunity. So you must place earlier possible valid rows. So this is similar to stable selection, but we have to use the bubble swap, right? That is why we have seen that we have done these steps and we found our answer. Okay, let's do the coding so we'll understand clearly. Okay, so let's understand that very first we have given the grid. It means we should find the length of the grid. So we can say we have this grid. So this grid dot, if we'll do the length, we can find the length, right? Because this is the grid we have given. Okay. So now we need a array that can store all the zeros, right? Number of zeros we can say. So can we say that this array is nothing but the trailing zero? We can say. So these trailing zeros will contain new int all the zeros, right? It will, we are initializing here, but it will store all the zeros. So we have to count and we have to store here. Let's do the count the trailing zeros. In this case, we need a for loop and we'll start int I is equal to 0 and I should be less than n and I plus plus like this. Okay. Then we'll find a count is 0 will do. Then we should do a loop. Over the loop we will find int j is equal to start from n and n minus 1 we should do actually n minus 1 and j should be greater than equal to 0 and j minus minus we will do and we will check if the grid at I and j equal to 0. It means we'll increase the count plus plus guys and else we'll break it here, right? Because we want to find that, right? Then we'll come here and we'll say okay, trailing zeros at the I is nothing but is count. So like that we will fill our count in the trailing zeros. Once this is done, we'll create a loop again and over the array like this we'll keep going and we'll say I should be less than n and I plus plus. Okay, then we need to find the required. So how we'll find the required, let's understand. So this is our required. We can get from n minus 1 minus I. This is based on we have created the table, remember. So we'll say int j is nothing but is I here. So if I'll say a while loop that j is less than n and trailing zeros at j, it should be less than required. That is the same condition we're talking about, greater than equal to, right? So required should be greater than trailing zeros. If this is the case, we'll just say plus plus. Now after the while loop, we'll say if this j is equal to n, it means we will return minus 1 if it is impossible. So if it is possible, we'll keep doing that j plus plus, otherwise return minus 1. Now the condition is very important to understand that. We'll say in a while loop, if j is greater than I, it means very first do the swapping. Swapping is very important because we have to do the bubble sorting it out, right? Because if it is uh, if we have if it is not matching, right? So from the temp we need a trailing zeros at some value will be there, let's call j. So we'll get the value we need to do the swapping. So we'll store first, right? We need to store the element first, right? Then we'll say, okay, the trailing zeros at j should be trailing trailing zeros at j minus 1, right? One shifting we will do, one swap. Then we'll say, okay, trailing zeros at j minus 1 is nothing but will provide the 10. So it is swapped now. Now j minus minus will do. How many we need, that we will do j minus minus, and then the we have taken a swap plus plus will do. Let's check we have created or not. Okay, no. It means we should define. Let's define here itself. Int swaps is equal to 0. Basically, see, swapping we are doing from here. Okay, very first we find that we have find that this is what we have given. Okay. We have done, we have checked the required. If required is not matching, we will do j plus plus, right, like that. And in the while loop we'll check how many swaps we required. Until that, if it is equal, right, in the for loop it will go again, we'll check the required. If it is match, right, like that, we will do the swapping until j is greater than I. I hope you understand. Now just once this loop completed, we return the swaps. Okay, let me go through running. What is the problem here? Trailing zero new int. Then it should not be the problem, right? No, guys. See here, when we have defined trailing zeros, yeah, I remember. We have to define this, right, at this array. Yeah, it's working. Let me submit this. It's working. Okay, so the very important part from here is to understand the complexity, right? So let's understand where we have seen the counting zero. We are taking the array loops, right? We are going through in the for loop line number 17, you see. Then we are coming in the while loops. We have couple of while loops we have. So internally it is taking off and scare. Okay, let me show you what I'm trying to say. So let's understand time complexity, guys. Okay, it is important to understand time complexity. So here we have taken a for loop. Inside that we have two while loop here and here, right? So due to this two while loop, it will become O of n square, right? Because we are doing the counting, very first counting zeros we are doing. So this counting zeros basically takes O of n square, right? And that is why we will say O of n square. Okay. Then we are doing the bubble swaps. This is called bubble swap. In the worst case, what will happen? It will happen O of n square, right? It means time complexity and space complexity both is taking O of n square, and which is acceptable. Okay, so that's all I have in this video. But in case if you are struggling with anything, you can ask me in the comment section. And if you want this PDF, you can join our WhatsApp community. You can just ping me, I'll add you there, and that's all I video. So in this video, you can go in the description, you can get the WhatsApp number, you can ping me, I can add you there, so you can get the PDF. Thank you guys, thank you for watching this video, and see you in the next one. Bye bye. Thank you guys, thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.